Hey y'all, welcome back. Today we're working on the homework for the law of cosine. So before we get started, I just want to clarify what you'll be given in terms of the quiz and the test. I'm not going to give you both forms of the law of cosine. I'm only going to give you this one. So this one's useful in the case where you need to find the missing side first, like in number 1 over here. But if you're given all three sides, you'll need to find one of the angles first. And so it might be useful to rearrange this to solve for angle A. So what I'll do is we'll do that up front, and then we can use that formula whenever we need it. So let me just go down to the bottom and I'll show you how that works. So again, I'm not going to give you both forms on any quiz or any assessments or anything. I'm only going to give you this form of the equation. So I just want to go through the algebra with you so that when you have to do this on your own, you've seen it before and you've practiced it before, and hopefully you don't run into any algebraic issues. So the idea here is we're going to solve for cosine A first, and then ultimately we'll take the inverse cosine to isolate angle A. So the first thing to do is going to be to move these two terms over to the other side. Okay, so I'm going to subtract b squared and c squared from both sides. And another thing I'm going to do is I'm going to move around the whole equation, okay? In other words, since I'm trying to solve for cosine A here, I'm just going to move this to the left side and move this to the right side. So just to kind of clean that up a little bit, it's always a good idea to have the variable you're trying to isolate on the left-hand side. So I'm not really doing anything algebraic here, just kind of moving around the equation. Okay, so trying to get this by itself, so the next thing I need to do is I need to divide both sides by negative 2bc. So I have a squared, minus b squared, minus c squared, all over negative 2bc. Now, a lot of times if you look this up in a textbook or something, this is going to be multiplied by negative 1 over negative 1, and so it will look a little different when you actually like if you were to look it up in a textbook or online. And so let me just kind of show you what that may look like if you look this up elsewhere. Is they'll basically swap all the signs here by multiplying this by negative 1 over negative 1. And I think the reason that publishers will do this is so that you have fewer negative signs in here. Okay, multiplying by negative 1 over negative 1 is just the same as multiplying by 1. And so what you'll end up with is the b and the c squared will end up being positive. And then we'll have minus a squared all over 2bc. Again, it doesn't really matter. You can use either of these forms. This particular one just has fewer negatives, and so it just leaves a little bit less room for error when you're typing everything into the calculator. Because ultimately, that's what we're going to do. When we want to solve for angle A here, we're going to have the inverse cosine. And this is something, again, you'll type into your calculator of this whole fraction. So this particular, this one is solved for A. If you want to solve for side A, really the only thing to do here is going to be to take the square root of both sides. So if I want a useful equation for A, not a lot I need to do algebraically here. I need to take the square root of both sides, and I'll be left with exactly this, but with underneath the square root. Oh, okay, well, let's try that again. All right, so the only other thing I'll mention here is that the side and the angle may not be called A. Like let's say you're looking for side B or angle B, for instance. The only thing you're going to change in this equation is the equation will be set up in the same way, but let's say we're looking for angle B here, then this negative 1 over here needs to be B, and then this would be A and C instead of B and C. So you basically just swap out the variables depending on which side you're looking for. Now if you're looking for like a triangle that's XYZ, then Whatever angle, like let's say we're looking for angle x, then side x will go here, and you'll put yz in these positions. So let's go ahead, and what I'm going to do is I'm going to actually copy these two forms of the equation up here. Neither of these are going to be given to you, so it's important that you know how to algebraically solve for them. This is the one that's going to be given to you. Okay, so we can kind of put this over to the side, and I'm going to write, so this is the one we're going to use for anytime we need an angle measure. And then the other one I'm going to use anytime I need a side. Okay, and so for the most part, it's just going to be a matter of making sure I plug in the right numbers in the right places, and so forth. So now we've got kind of a good setup here. This is going to be for an angle. Okay, maybe I'll type that in here. To find an angle, we're going to use this one. To find a side, we'll use this one. It's the same equation, it's just, as you saw a moment ago, just algebraically manipulated around to meet our needs, okay? So let's just start with number one. So we've got an angle A is 140. We know side B and side C. So the things that we're looking for, and I'll make a little answer key down here somewhere, is we're looking for the measure of angle B, we're looking for the measure of angle C, and we're looking for side A. Okay, so the first thing we want to do here is we want to be able to hopefully set up a law of sine scenario. Although, oops, you could use law of cosines multiple times, but let's try to find angle B first. Okay, and that way, once we have angle B, we can start either using law of cosines or law of sines, depending on what we decide to do here. So I'm going to use this little formula that we got from earlier. Now notice this is set up for angle A, and we need it set up for angle B. So the changes we're going to make, we're going to modify this just a little bit, and we're going to solve for angle B, which means that I'm going to swap A and B here every instance in the equation. So angle B, and this needs to change to B, this needs to change to A, this needs to change to A, okay? So now we've got it set up for angle B, and we're just going to plug in everything we know, and luckily, oh, now wait a minute, we don't have side A. So you know what? We can't actually use this yet because we do not have side A. Now we're going to use it eventually, so I'm just going to scooch it over here. But upon inspection, we actually need to find that missing side first. So let's find literally side A. We don't need to make any modifications to this one because it's already set equal to A. So we're going to just plug in everything that we know for side A. Okay, that's going to be 12 squared plus 14 squared minus 2 times 12 times 14. And I'm going to have to make this a little smaller. Gosh, I really didn't give you all enough room to work these. Okay, so now this is just going to turn into a calculator problem. I'm going to just type this in. Let's see here. We've got the square root of 12 squared. And yeah, I'm just going to type this in exactly how I see it. 14 squared minus 2 times 12 times 14 times the cosine of angle A, which I didn't retype in there. I'll go ahead and fix that, but it's going to be the cosine of 140 degrees. And before I hit enter, I am given this angle measure in degrees, so I got to make sure that my calculator is in degrees. So mode, yep, default's radians, so just make sure you check that. All right, so that means that side A is approximately 1 we'll just go to one decimal place here, 24.4. Now, I do want to caution you because I'm going to put 24.4 here, but when you go to plug that in over here, you want to try to get as exact as possible because once we set this up, if we use 24.4 here, this is going to have a little bit of a rounding error that is going to compound and throw this off even more. So I want to show you that we could actually solve for this missing angle in two different ways. We can either use law of cosines or the law of sines. So if I use the law of cosines, you just be real careful with this a value, and what we would have to be careful with the law of sines too. But I just want to show you something when we get to that. So let's go ahead and let me show you how you could type that in a little easier in the calculator. So what we could do here is we can actually store this value in the calculator so we don't have to type the whole thing again. So I'm going to store this. You hit the stow button. It's right underneath the natural log. So it'll come up with this little arrow. All right. If you're looking for the button, I know you can't see it on my screen, but it's right by the 4 and the 1. It just says stow, S-T-O. And we're going to store this into letter A. Okay. So I'm going to hit alpha, and then the A button is right underneath. There's a little green A above math. So hit that, and this is going to basically just save this number for A. So when I go to type in this equation over here, instead of typing in 24.4, I'm going to actually give it the exact value so I can make sure that this is as accurate as possible. All right, now when I write it, I'm not going to write the whole thing here. C here is, what is C? C is 14, B is 12, I'm going to type in the 24.4, but when I actually put it in the calculator, I'm going to be more precise about it. Okay, so let's see here. Let's bring this down over here. All right, so let's go ahead and type that in now. We've got the inverse cosine of, a big old fraction here. So just be very careful with how you type this in. Now, so again, I'm not going to do 24.4 here. I'm going to use my saved value so that it's as accurate as possible. Plus, so this A, again, is representing this number. 14 squared minus, got the squared, minus 12 squared over 2 times A, right, that's that 24.4, times 14. All right, so my angle B comes out to be about 18 degrees. Now, if I had just typed this in and I used 24.4 instead, I just want you to see how much of an error we end up getting. Honestly, I'm not sure exactly how off it will be, but we'll find out right here. So it's not, it's not tremendously different, but it is quite different. Like if you're rounding, this one rounds up to 19 and this one rounds down to 18. So just be careful there. The more exact you can, the more exact your inputs, the more exact your outputs will be. So I'm going to round down to 18 degrees. Okay, so for C, once we have our first two angle measures, getting the third angle measure should be no problem at all. It's just going to be 180 minus angle A, which is 140, minus angle B, which is about 18 degrees. Again, if you want to be even more precise, we could plug this in. We could store this into C, although I don't think we're going to get any benefit out of that since we're rounding to the nearest whole number. But yeah, you could do something like 180 minus 140 minus 18, or just, type this one in. And we get it rounds up to 22, which we would have got anyway. So yeah, so angle C is going to be 22 degrees. Now, I did say you could have used law of sines here, and I'll show you that for this one problem. But since we're trying to practice the law of cosines, I'm going to mostly be doing law of cosines throughout this and basically working it out just like I worked out this one. But if I use the law of sines to find angle B, we should still get 18 degrees, but let's see how that would work out. So the law of sines would have side A, which is the 24.4, and then divided by cosine of A equals B divided by cosine of B. So, well, I'm saying a lot of this. Let me just kind of show you what I mean. So we would have A over sine A, and then we'd have B over sine B. So if I'm solving for this B right here, I would do little side A times sine of angle A divided by side A, and then I'll take the inverse. You did that a lot in the last couple lessons, so I'm not going to go through every little step here, but it would be 12 times the sine of angle A, which is 140, divided by side A, which should still be stored in there. Okay, and then if we take the inverse sine of that, we should still get 18. And yeah, we get the same number, okay? 18.396, 18.396. So yeah, it doesn't matter if you use law of sines or law of cosines. If you like the law of sines better, then just do law of sines to get that angle measure. But I'm going to stick to law of cosines, at least for this video, just so that you can see how you would use a law of cosines to solve these. I'm going to have to make this a little smaller because I need some room for the next problem over here. Now that might be too small for you guys to even see. Well, let's bump it up one step here, and you know what we'll do here. Just move all this over a little bit. There we go. Yeah, there we go. Okay. Just giving ourselves a little bit of room here. Try to make this a little nicer. Okay. So there's number one. Let's take a look at number two. All right. So with number two, we're going to solve it a little bit differently because this is going to be a side case where we're given all three sides. So we're going to have to just kind of jump on this angle, and it looks like we're going to basically have to do it twice. Okay, we could use law of sines to get the second one, but I'm going to stick with the law of cosines just for the sake of practice. So I'll go ahead and find angle A first, but I know I'm also going to need angle B, so I'm just going to get that ready to go. Nope, what happened there? So for angle B, just make sure, actually we already had it over here, but you want to swap A and B in the equation. So since I already solved for it, I'm just going to put it over here. Okay, so at this point, we're just going to be plugging stuff in and using the calculator to actually find these angle measures. To get the third angle measure, can I move this? What's going on here? To get the third angle measure, we'll have to subtract both of these angles from 180, but that should be the easiest part of the whole problem here. Okay, so let's, I'm just going to copy this, and we'll replace all the numbers with what we know. So side B is 6.5, side C is 11, and side A is 7.2. And so down here we've got side B is 6.5, and side C is 11. Okay, so this is just going to be something we put in the calculator. So let's pull that back up. Very calculator heavy. This whole unit, you're using the calculator quite a bit. Okay, so I got the inverse cosine of, set up a big fraction here, 6.5 squared plus 11 squared minus 7.2 squared. Divided by 2 times 6.5 times 11. Oh, these buttons are slipping on me. Maybe it's me that's slipping, I don't know. 2 times 6.5 times 11. Okay, so we get about 39 degrees. So 39 degrees here. And then let's find angle B. Okay, doing this exact same thing, except we're plugging in the correct sides. So here, side A is 7.2, side C is still 11, side B is 6.5, over 2 times, let's see, what was A? 7.2 times C, which is 11. And I don't know if this is going to fit. I might have to make this a little smaller. Yep. Now luckily, after we do these first two problems, all the rest will be solved very similarly. Okay, you're either going to have to get the side first, like we did over here, or just start working on the angles. Now here, we're not referring back to angle A, so we don't need to worry about the whole rounding thing. We don't need to store any values or anything. If you were to use law of sines, you would have to worry about that. But we're not working with law of sines here. We're not referring back to that 39 degrees, so we shouldn't have anything to worry about. So let's see here. We got 7.2 squared plus 11 squared minus 6.5 squared. I'm just copying over what I had from the last one, so I don't have to retype everything. Oh, nope, let's try that again, 7.2. All right, and here we go. We get about 34 degrees. Now to get that third angle, I am a little curious to see if the rounding is going to make a big difference. So we'll just kind of see. We'll calculate it both ways and see if the rounding matters. It's always good to use the exact values, just as a general rule of thumb. So 34 degrees here. Okay, so what I'm saying is to get this third angle, to get angle C, what we really want is 180 minus 39 minus 34. But if we just type that in, and I'm not sure if we're going to actually get a significant rounding error here, but let's find out. If I just use 39 and 34, I'm going to get 107. If I do, here comes the moment of truth here, 180 minus this 38.8 minus the 34.46, that still rounds up to 107, so not a big deal here. But it is nice to see what the exact angle is, or at least a better approximation of it. So yeah, so we get 107 degrees. And I guess really that should be an approximation here. Okay, so we basically have all the three missing components here, and we're pretty much done with this problem. Let me just write up the final answer to kind of, just sort of finish this off here. We've got angle A was 39 degrees, angle B was 34 degrees, and angle C was approximately 107. There we go. Okay. So there's number 2. From here on out, you're going to be doing essentially the same thing on all these problems. So it's kind of, maybe too much, but we'll go through them. Let's just go through them one at a time. All right, so let's take a look at 3. We've got angle B, angle C, and side A. So wait a minute. This is not going to be one that we can solve with law of cosines. Because if we have angle B, we'll call that B. We'll have angle C, and side A would then have to be this one. This is an angle side angle situation, and we're not going to have enough information to use law of cosines. Because if we try to get like either of these other sides, we're going to be stuck because we don't know the second side. And yeah, so we're going to have to use law of sines on this one. So this becomes a law of sines problem. So make a little note. Must use law of sines. Now, if we have a choice, I'm going to use law of cosines just for today because that's the focus of the homework. But if we have to use law of sines, then we got to use law of sines. Okay, so yeah, this is gonna be one where we have to use law of sines. So let's get, well, we're gonna need angle A first to be able to use law of sines, so we have our pair. So let's go ahead and do that. So angle A is gonna be 180 minus 33 minus 46, which is gonna be, what was that, 79, so 101? Am I doing that? Let's check it. It'll be right around 100. Yeah, 101. Okay, so we get 101. So we got angle A right off the bat. And even if we wanted to use law of cosines, we couldn't here. I guess we could on the last one, but even then, we might as well just use law of sines. Okay, so let's go ahead and start setting it up. We've got 8 over the sine of 101. And we've got, well, let's put a little degree measure in there. I guess I was pretty inconsistent about doing that across the board, wasn't I? I guess it was just that one pot. All right, so we have 8 over sine of 101 equals, let's just start with side B. So B over the sine of 33. Do a little cross multiplication here, and we get B equals 8 times the sine of 33 divided by sine of 101. And we're going to solve for side C similarly. So before I break out the calculator, I'm just going to copy what I have here and just replace the important pieces. So I'm still going to use this side A, angle A combo for my first ratio, but for my second ratio, I've got side C over the sine of 46. So it should be 8 times the sine of 46 divided by the sine of 101. And that'll be how we find C. So now let's just put both of these in our calculators and we're going to be done. Okay, so yeah, these law of sine problems, they usually go a little faster for some reason. I don't know. There's just a little bit less typing and algebra. I don't know. They're just not as bad. Okay, so for this first one, I get about 4.43. I'm just going to go ahead and type in the next one. 8 times the sine of 46 divided by the sine of 101. Okay, so side B is approximately 4.4, and then side C is approximately 5.8, rounds up to 9, and there's your side lengths. So that's number 3. Got to use law of sines on that one. Okay, so angle A is actually exactly 101 here. Side B is approximately 4.4, and side C is approximately 5.9. All right, so that one's kind of boring. I don't know how that problem snuck on here, but yeah, for this one, you've got to use the law of law of sines for this one. Okay, now let's go on to number 4. For number 4, we've got we got 2 angles at another side. Are we going to have to use law of sines again on this one? Hold up, let's try to visualize what's happening here. We've got angle A. We've got side A, and we've got angle B. So it doesn't really matter which one we'll call it this one. So this is going to be an angle side. We're going to use law of sines again. Yeah, because to get this missing side, I need to know the 2 other sides. So we could use law of cosine on the second one, but gosh, this is another law of sines problem. Again, that's kind of annoying. Well, it's good practice. Let's keep up with our law of sines here. So yeah, we're going to basically solve this exactly the same way as number 3. Okay, so angle C is going to be the difference between 180 degrees and the sum of 102 and 36. So let's see, that'd be 138. So I'm thinking 42, but I'll double check. I think it's going to be 42 degrees. Yeah, 42 degrees. All right, so we got angle C is 42 degrees. Now we need to find side B and side C, and the ratio we're going to use for both of those is going to be the one that we have for A. So 16 over the sine of 102, 16 over the sine of 102. To find side B, I'm going to use B over the sine of angle B, which is 36. And then the angle C is, let's throw in a little symbol there. And then angle C is going to be what we just found, which is 42 degrees. Okay, so side B should be 16 times the sine of 36 divided by the sine of 102. And then side C would be 16 times the sine of 42 divided by the sine of 102. So here we go. We're getting ready to solve these. Let's go ahead and type these in, and then we will finalize this problem. A lot of signs, for some reason, just seems to go a little faster, I feel like. These problems are, especially since you find both sides basically the same way, and then it's just a matter of plugging in the right numbers. Usually doesn't take terribly too long. So we're going to call this 9.6. And then for side C, only difference here is the sine 42. All right, so we get about 10.9. All right, and there you go. So there is, just make this a little easier to read here. There we go. There's number 4. So number 5, we're getting back to the law of cosines here. Could probably just skip 3 and 4. We already did so much practice with law of sines already. But this is going to be a problem like number 2, where we're given all 3 sides and we need to find the 2 missing sides. So that's why I'm going to go ahead and just copy what I've got over here. Looks like I copied a little too much. Not a big deal. Okay, so yeah, what we're trying to do is we're trying to find angle A, angle B, angle C, and we're basically going to work these out the same way as we did problem 2. In fact, problem 6 is going to be identical, except we have X, Y, Z instead of A, B, C. So these formulas are still going to work, but I need to plug in the correct numbers here. So B is 13, so these two would be 13. C is 7 in this case, so I'm going to change these to 7. And then A is 11. And if I'm trying to find angle B, side A is 11, side C is 7, side B is 13. And then we've got 2 times A, which is 11, times C, which is 7. Okay, and then let's just delete this for now. We're going to plug all that stuff into the calculator to get our answers. Just kind of cleaning this up. All right, looks good. Let's pull out the calculator and let's get a solution here. So we've got the inverse cosine of 13 squared. Oop, not 3 squared. You know what I'm going to do here? I'm just going to make a fraction. Feel better about it if I do it that way. 13 squared. Oh, come on. It just doesn't like the clicks. All right, doesn't want to get clicked. All right, now I'm having trouble here with the notation. Here we go. Okay, so 13 squared plus 7 squared minus 11 squared all divided by 2 times 13 times 7. And that's going to give me angle A. Oh, looks like I missed a parenthesis there or something. Let's make sure that I calculated right. I don't want to waste time like digging through the syntax. I think it'll be all right, but yeah, it's okay. Okay, so we get about 58 degrees for angle A. For angle B, we're going to kind of do the same thing here, except put in the correct numbers. Okay, so we've got 11 squared instead of 13 squared. Basically going to swap the 13 and the 11. So 11 squared, and then we'll have minus 13 over here, and then 2 times 11 times 7. So we get about 89, oh, almost 90 degrees. Not exactly 90 degrees. This is where it's kind of important to put this approximately so we know it's not a right angle, but it's pretty darn close. Pretty close. Now, Pythagorean theorem, unfortunately, is still not going to work. SOHCAHTOA, all that stuff. Only works with right triangles. And while this is close, it's not exact. So anyway, let's do 180 minus 58 minus 90, and we'll get our third angle. Which is about 32 degrees. And there we go. So we got all three angles. So 58 and 90, and finally 32. Okay, now problem 6, we're going to work essentially the exact same way, except we're just going to make sure that we modify our parameters or variables to match up with the three that are given. So instead of A, B, C, we'll have X, Y, Z. Not a big deal, we just got to be careful. Just got to be careful. Okay, so let's say we're going for angle X first. So basically the mapping here is going to be X is A, Y is B, and Z is C. Although it really doesn't matter, you just got to pick a mapping and go with it. But to me, I just think it's easier to just stay in alphabetical order. That way I'm not constantly thinking, oh, which one's A, which one's B, and so forth. So yeah, this will be Y squared plus Z squared minus X squared over 2 times Y times Z. And then if I'm going to find angle Y, that's going to be the inverse cosine of X squared plus Z squared minus Y squared over 2 times X times Z. So when I go to find Z, that's going to be my last one here. So I'll have 180 minus whatever, whatever I end up getting here, and that's going to be my Z angle. Okay, so let's start plugging stuff in and fixing this up. So Y is 6, Z is 21, X is 14, over 2 times 6 times 21. And then for angle B, let's just go ahead and fix this as well. 14 squared plus 21 squared minus 6 squared. And I think I need to fix this as well. Okay. Did I fix the bottom there? 11, no I didn't. I got carried away. So X here is 14 and Z is 21. All right, so let's go ahead and start typing away. Okay, we're ready to go and trying to find these missing angles. So inverse, I'm just gonna not type the whole thing again. Got to take advantage of that copy paste here. Got to be careful, but it can definitely save a lot of typing time. So we get 6 squared plus 21 squared minus 14 squared over 2 times 6 times 21. Domain? What? All right, what happened here? Did I mistype something? I bet I mistyped something. Let's look a little closer here. So Y is 6, yeah. Z is 21. Maybe there's no solution here. That is possible. That can happen. Yeah, is there just no solution here? What did I? You know what? I don't think there's a solution here. I don't see anywhere where we mistyped anything. If we were to check angle Y, I bet that's going to give us a problem too. Let's check angle Y. So this is going to be no answer, nothing, no possible answer. I don't know what there's nothing. Okay, there's basically we want to say that's the null set. Okay, this is like no solution here. But let's see, does Y come out okay, or do we get the same thing? We're going to talk about why we're getting no solution here. But let's see here. So if I do 14 squared plus 21 squared minus 6 squared. Did I get an extra one? There we go. 2 times 14 times 21. I bet we're going to get another error. Boom. Yep. Okay. So this can happen. Let me explain why this happens. There's no possible triangle here. It's supposed to be like that. Okay. There's nothing here too. Nothing to work with here. Okay, so I guess what we'll say is there's no possible triangle. Let me try to explain why, though. Okay, one thing that that you learned back in geometry are the requirements for having a triangle. Okay, so the requirements for having a triangle, I mean, bottom line is if you add up any two sides, they've got to add up to more than the third side. Okay, because if I have like a side that's 14 and a side that's 6, and it's just barely angled out, like enough to make a triangle, this side right here has to be at the maximum, it has to be 20, okay? In fact, even if it's 20, it's not going to work because in order for this to be 20, these sides would have to be just like laying down flat, and then you would have a 180-degree angle measure in your triangle, which wouldn't create a triangle. So this has got to be actually smaller than 20, okay? And since this third side is 21, you say, okay, well, that side is just too big to construct this triangle. So that, yeah, I guess this could happen. So in this case, there's no possible triangle. There's just essentially no solution here. Okay. In fact, it might even be worth just like deleting all this extra stuff that I'm crossing out here. Yeah, there's nothing. No possible triangle. Now, you don't really need to memorize the rule as far as like, you know, when is there a triangle, when there's not, like all the sides. If you type it in, you're getting no solution. Just double check that you're plugging everything in right. And if you're reasonably confident that you are plugging in everything correct, then you're probably right that there is just going to not be a triangle. So I wouldn't stress about it too much. If you're very careful about how you're typing this in and you get an error, then that just means there's no triangle there. You can always double check by looking at the side lengths. And if the biggest side length is more than the sum of the other two, then if you identify that right away, then you say, okay, well, there's definitely not going to be a triangle here, and you don't have to go through the work. But if you don't catch that, you'll just get an error message in the calculator when you try to compute this. So like if we look at number 7, if I just want to look and say, hey, is there actually a triangle here? I look at the biggest side, 16, and the sum of the other two sides is 22. So since this is smaller than that, then we're safe. We know there's going to be a triangle here. Let me see if there's another example like that. Like let's look at this one down here. Biggest side is 8, which is smaller than 10. So we definitely have a triangle there. Do we have any more? Yeah, down here. Gosh, I gave you a lot of problems, didn't I? My bad. 47 is smaller than the sum of these, so that's safe. 13 is smaller than the sum of these, so that's safe, and 9.1. So this is going to be the only one, I think, that we're going to get no solution. Okay, so there's number 6. Let's take a look at number 7. This one should have a solution here. So hopefully we can just copy our work over here and kind of just get at it. Okay. So, you know what I'm going to do? I'm going to try to clean this up just a tad. Thanks. Okay. So our formulas here are still good. We don't have to redo those. We just need to plug in the correct values here. So B here is 12, C is 16, and A is 10. So we have over 2 times 12 times 16. And then over here, we've got A, which is 10, C is 16, and B is 12. So we have 2 times 6, 10 times 16. You know, just notice every time, like, these are going to be the same numbers. Yeah. Okay, anyway. So I'm going to delete these just so I don't kind of get lost here and lose track of what I've found and what I haven't found yet. Okay, so now let's go ahead and start typing stuff in to the calculator. In fact, no, I'll just leave it like that. Let's go ahead and do it. All right, so I'm just going to steal this, and hopefully we don't get... I'm not expecting an error because the side lengths seem to check out. 14 squared plus 16 squared minus 10 squared. Do I have an extra space there? What's going on with that 10? Oh, there we go. Over 2 times 12 times 16. Now, assuming everything goes as expected, I should get a number here. Okay, so I get approximately 23 is going to round up to 24 degrees. So I've got my A. That's going to be one of the angles I subtract to get C, but I need to find the other one as well. So only change here is I'm going to swap out the 10 and the 12. All right, hold on. Let's go over here. Okay, so I get 10 squared plus 16 squared minus 12 squared over 2 times 10 times 16. And I get, oh, that's going to round up to 49. Barely rounds up on both of those. So my angle C is going to be the difference between the sum of both of those and 180, so we get 107 here. All right. Okay, well, there's number 7. Wait a minute. Oh gosh. Look at this. I didn't type that in right. There's a 12 there that somehow is a 14. Maybe that was from the last problem and I just didn't type it all the way. So this is going to change. Let's fix that. So, okay, so this is going to actually be 39 degrees. Okay, let's go ahead and fix that up, 39 degrees. And then we got 49, which is going to affect our final answer here for angle C. 39 and 49 gives me 92 degrees. Okay, so this is off. You know, it's worth giving it a second look. You know, I had it written correct here, but I just had not typed it right here, and just something was not adding up to me. But we caught it. We're good. I believe this is the correct answer now. So I'm just going to do a little quick scan here. I don't see anything that's standing out to me. So I think we're good. All right. Now let's do number 8. So number 8, we know 2 sides and angle. This is a side angle side. So what we need to do here is use the law of cosines to find one of the other angle measures first. I think we've done that at least once. We did that here, we did it here. Since we only have one of the angle measures, we're going to have to take this approach and not worry about getting that second. You know, we're not going to use law of sines here. So yeah, let's just find side A first since we know angle A. And then we'll get angle B. We kind of follow the same path here. So let's see here. Side B is 15. Side C is 30 times 2 times, or minus 2 times 15 times 30 times the cosine of 30. Actually, I might be able to get away with using no calculator here, because cosine of 30, well, I take that back. Cosine of 30 is going to be root 3 over 2, so that's going to be a mess. If it was 1/2, I would say, okay, well, maybe we can do something with that. But all right, so we get the square root of 15 squared plus 30 squared minus 2 times 15 times 30 times the cosine of 30 degrees. All right, so we get about 18 we'll call it 18.6. Okay, so now we need to find the secondary angle, angle B. And so we've already got the setup here. We're just going to plug in the correct values. Now with this 18.6, like we did in the very first problem, I'm going to use the store function. I'm not going to type in 18.6 because I don't want too much of a rounding error. I want to minimize the amount of error that, that I can. So 2 times, let's see, A is the 18.6. I'll have to use that store function again, times C, which is, what was it, 30. Okay, so in my calculator, I'm going to store this 18.6 so I can use the exact value. I'll just stick it into A. So when I type in my cosine, my inverse cosine formula here, now I'm just going to, instead of typing out 18.6, I'm actually going to use just A so it can be as precise as possible. So plus 30 squared, oops, minus 15 squared over 2 times, just call letter A, times 30. All right, so we get an angle of about 24. Okay, so that's 24. So angle C is going to be 180 minus 30 minus 24. Okay, so then we get angle C to be 126. All right, so angle B, we said was about 24 degrees. Angle C was about 126. All right, so number 9 is another side, side, side. And so we'll solve it just like number 7. So let's jump into that. All right, put that back out there. Number 9 is going to be a side, side, side situation, similar to number 7. And so we're going to work it out pretty much exactly the same way as this. Anytime you've got these side, side, side problems, that's going to be how you work it out. One thing that I've been a little careless about is you really should be finding the largest angle first. In some cases it doesn't matter, and I don't think it does on any of the ones we did so far, but you just want to be careful about that. You might run into a situation where this whole solving process kind of fails you. So make sure that you are finding the largest angle first, just in case you have an issue with that. So in this case, we'll just start with angle A, and we're just looking for ABC here, so we'll just kind of fill in the numbers and hopefully not make any calculator errors like we did on the last one. So, or not the last one, but 2 times ago, right? I messed up typing this one. It should be 92. Okay, anyway, let's do this one. So B here is going to be, let's see, 3, C is 8, A is 7, so we have 2 times 3 times 8. Oh, wow, what what happened here? There we go. Okay, so let's go ahead and turn on the calculator and we'll type that in. Inverse cosine of, throw in a fraction, 3 squared minus 8 squared minus 7 squared all over 2 times 3 times 8. And domain, okay, maybe I mistyped something. Oh, you know what? I know what it is. My calculator reset here. I need to go back to degrees. Pretty sure that's going to be my issue here because it looks like I typed it incorrectly. Oh, no, I didn't type it incorrectly. There's another error in here, too. It should be plus. Gosh, I'm really struggling with these calculators. There's too many problems in a row, I guess. Okay. Oh, look at that. Wow, we get a 60. Oh, okay. Is this going to be a 30, 60, 90 triangle? Kind of looks like it. We could check the Pythagorean theorem, but I don't think that's a triple, so I'm guessing this is not going to be a 30, 60, 90 triangle. Okay, so this one's 60. Might as well delete all this. All these are not accurate. So we get 60. We'll find B next. Just want to delete these because those are not going to be right. Okay, so for angle B, we do kind of the same thing here. You plug in all the appropriate numbers. A is going to be 7, C is 8, and B is 3. So we get 2 times 7 times 8. And we'll type that in. All right, let me try to be real careful here. I made so many calculator mistakes as we get through this. I really want to make sure I'm doing this right. Okay, so 7 squared plus 8 squared minus 3 squared. Yeah, it should all be good. And then we got 2 times 7 times 8. Yep. Did I do the last one right? Yes, I did. Okay. Just want to double check that because, you know, you guys have seen what's been happening. Okay, so we get about 22 degrees here. So we get about 22. And then so my C should be 180 minus 62, or minus 60 minus 22. All right, so we get about 98 degrees. So not quite a right triangle, but pretty close. Pretty close, almost 90. Yeah, this is almost a 30, 60, 90, but it's a little off. And you could tell pretty easily that's not going to be a right triangle because the Pythagorean theorem fails. 3 squared plus 7 squared is not 8 squared. Okay, so there we go. There's A, B, and C for number 9. Now, number 10 and number 11. Okay, so number 12 is just a lot more the same, except it looks like we're only searching for one thing here. Ooh, that'll be nice. And 10 and 11, though, are a couple of word problems where you use a lot of cosines. So let me try to talk your way through that. All right, so it says parallelogram with sides 8 and 25 has diagonals with lengths 20 and approximately 31.273. Okay, I'm guessing that's going to be an irrational number, and we're going to have to round that. Find the measure of the angle formed by the intersection of the diagonals. Okay, so, you know, there's really, I guess, 2 angle measures here, but let's sketch this out. Let's see what's really going on here. So we've got a parallelogram, so it'll look something like this. This is just approximation, doesn't have to be perfect. Okay, here's a parallelogram. It says the side lengths are 8 and 25, so I'm going to make the short side 8 and the long side 25. It says the diagonals are 20 and a little over 31. So this one is going to be the 20, that's going to be the shorter diagonal, and then the longer diagonal is 31.273. So when I go to label this, okay, so here's the deal. We're trying to find the angle formed by the intersection of the diagonals. So in other words, we either need to find this, or I guess we could try to find both. They're going to add up to 180, so if we find 2, we could find the other one pretty easily. So it says the diagonals are 20 and about 31. So basically what I'm going to do is I'm going to solve one of these triangles. Okay, I'm going to solve like this one, for instance. And you could solve the other one as well. You should end up getting the same answer that we do if we do this one, but I'm going to focus on this one. So the side lengths here of this triangle are going to be half of the diagonal lengths, because like if this whole thing is 20, then this side's got to be 10. So I'm going to say this is 10, and then this would be the 31.273 divided by 2. Let's see what that would be roughly. 31, oh wait, where's my calculator? There we go, 31.27, oh, nope, didn't like that. 31.273. Oh, it doesn't like that 7. There we go. And we're going to cut that in half. So you get about 15. Well, might as well just go all the way to try to be as accurate as possible here. 6.365. Okay. So in this blue triangle here, we've got a side, side, side scenario. So we can use the law of cosines to find this angle, and then we'll just subtract from 180 to get this next one, because as you can see, they both lie along the line, so they're a linear pair here. So let's use the side, side, side. So that's going to be like what we did here. Okay. Now the angle measure in question, I'll give it a name. I'll just call it A, I guess, just to keep it simple. You can call it whatever you want. I'll call this A, and I'll call this B. Okay, but you can name it whatever you want. It's just asking what the angle measures are. Okay, just for the sake of the formula, I'm going to say that's A. Okay, the side that's opposite of that is 8, so I need to make sure that this one is 8. The other ones are 15.6365, and the other one is 10. So this would be 15.6365 times 10. Okay, so I'm just going to type all that in to the calculator and get a solution here. It's pretty straightforward. I mean, as long as you could draw this diagram, you're not really doing much different than what we've been doing. It does look a little scarier because it is a word problem, but once you sketch it out, it becomes pretty clear what you're supposed to do. So let's fix all this. This is going to be 15.6365 squared plus 10 squared minus 8 squared all over 2 times that roughly 15.5 number. Okay, that looks good, times 10. All right, fingers crossed, and we get about 26 degrees, okay? So that means that that smaller angle is about 26, so the larger angle, okay, would be 180 minus 26, which would be about 154. Let me double check. I think it's 154. So 150, yeah, it rounds up to 154. Very good. Okay, so we were expecting an obtuse angle there anyway. So we got our two angles. That's it. That's all there really is to it. You're just going to sketch your parallelogram, identify what angle it is you're trying to look for. In this case, I'll just report both of them back. I'll just say that, yeah, my answer here is going to be 26 degrees. Oh, oops. 26 degrees. I'll just steal this. I think, honestly, there's probably a typo in here. I think, because the grammar here doesn't really make sense, find the measure of the angle. There's really two angles. I would say find the measures of the angles formed by the intersection of the diagonals. Grammatically, does this need to be an S2? The measures of the angles? Probably. But anyway, I'm just going to report both of them back. Hopefully on the assessments, I'll be a little clearer. Okay, so we got 26 degrees, and the other one was 154, roughly. All right, 26 and 154. All right, well, let's look at the next parallelogram problem. It's going to be kind of the same. We'll probably set it up very similarly. but let's take a moment to just kind of read it out here. One diagonal of the parallelogram is 5 centimeters long, the other is 13, they form an angle of 42. How long are the other sides? Okay, so actually, while it's still a parallelogram problem, what's the given information is a little different here. Oops, what happened here? Well, that's a weird way to do it, but I guess that'll work. Huh. Bizarre. Okay, so let's put in all the known information. I'm just gonna kind of get rid of all this. Okay, so one diagonal is 5 and the other is 13. So the shorter one's 5, so this would be like 2.5 and 2.5. And then the other one's 13, so this would be like 6.5. They form a 42-degree angle, so that would have to be this one because this other one is obtuse. So this is going to be 42 degrees. I can write that in there. 42 degrees. Ugh, gosh, it's hard to do that with a mouse. Okay, so here we have a side angle side, and we want to know what are the lengths of the sides. So we're really going to have to solve this twice because we've got this blue triangle, right? And we know the side angle side, but then we also have this green triangle over here that will help us get that other side. On the last problem, we could just subtract the angles from 180 to get the other diagonal here, or the other angle measure here. But here we don't have like a relationship like that to bridge these two sides. So we're just gonna have to solve them separately. So it's just a simple side angle side scenario. So when you get side angle side, you're gonna work it similar to this. We only need the side length. So we're not gonna have to do like solve the full triangle. We really just need this first part. So the short side, so I'm not even gonna call this A, I'm just gonna call this the short side, is going to be 2.5 squared plus 6.5 squared minus 2 times 2.5 times 6.5. It doesn't really matter which one's B and which C, times the cosine of 42 degrees. So that's going to be what we do to get the short side. To get the long side, we will solve a similar law of cosines, but the angle measure is not explicitly given, so we got to make sure that we actually write it correctly. So the long side is going to be, well, 6.5 squared plus 2.5 squared. Again, it's the same as the last one. Doesn't really matter the order here. I think I might switch it up though, just so you can see that it doesn't matter. Times 2.5 times the cosine of, okay, so what is 180 minus 42? Let's double check that. I think it's 138, but always worth a check. Yeah, 138. So since it's 138, put 138 right here. And then now I'm ready to just start, plugging that in my calculator. Don't even need this other step. Okay, so the short side, let's go ahead and type it in and see where we end up. 2.5 squared plus 6.5 squared minus 2.5 times 6.5 times cosine of 42. Before I hit enter, just do a quick check. I am in degrees, so we're good there. And it looks like we get about 6, okay, 6.0, okay, is going to be the length of the short side. All right, okay, so 6.0. All right, so I get about 6.0 there. And then for the long side, I'm going to do something very similar, except I'm just, really the only difference is the cosine of 138 instead of 42 here. So that's literally the only thing I have to change. So I'm going to change this to 138. And I get about 7.8 for the long side. And they do give us some units here. So I guess we can include that as well. Centimeters and centimeters. What the? My centimeters disappeared. All right, well, this is, I'm spending way too long than I should typing this out, but okay, so there's your two, those are the two side lengths, 6 and 7.8. So let's see, that would be 8, 9. Yeah, okay, so I guess that checks out. Okay, so there's number 11, and let's look at number 12. You know, okay, hold on. Gosh, how many mistakes are we going to make here? I'm missing something in my formula. What I'm missing is this 2. 2 times BC. So let's see what I have here. Yeah, I'm missing a 2. I had it over here. I lost it over here, so I'm not sure what happened there. But not a big deal. We can go back and we can fix that. So hopefully someone out there is keeping track of how many mistakes I've made so far, but we're getting pretty close to double digits here if we're not already past that. So yeah, I gotta multiply, I guess both of these are gonna be multiplied by 2. I gotta squeeze in a times 2 here. So let's make sure I'm doing the 42 first. Okay, so here's the 42 one. So what we want is, we want a times 2 in here. So 2 times 2.5. Okay. So now we have 4.9. I think that is going to be right. I'll go back and check it later, but I'm pretty sure it's going to be 4.9. And then I missed it over here as well, because I just copy and pasted. This is the danger of copy and pasting, because I did have it written over here. I got the times 2. But I just didn't have it in the equation here. What's going on here? Second, insert. Okay, there we go. So yeah, it should be 2 times. Okay, so I get 8.5. All right, I'm a little bit more confident about that. Something about those numbers just was not looking right to me. They seemed a little too small. But this looks a little better. Okay, so this is what we're going to go with on this one. I'm pretty sure the other one's okay. All right, so the last section here. Here we're just finding the value of x. We don't have to go through the entire solving process. We don't need to find the other angles or anything. We're just looking for that side. So these should be like some pretty rapid fire calculator problems. So this one is going to be a law of cosines problem where we are going to solve for a side length. So what was the last time we did that? That was a side. Here's a side angle side. It's just kind of convenient to rewrite these. Okay, so in this case, we don't have a, we have x. And the other sides are not even labeled, so we just have to know that it doesn't really matter what the other two sides are. Actually, it looks like 1, 2, 3. All these are going to be solved the same way. Okay, so might as well just get ahead of the game here and set this up for all of them. And really, we're just going to make sure to plug the correct numbers in, and then we'll kind of solve all these together. Like I said, rapid fire calculator problems here. Okay, so here we got 17, 22. This will be times 17 times 22, and then my angle measure is 42. For the next one, my two sides are 20 and 23. Doesn't matter which one's which here. Multiplication is commutative, so it could be either one. 23 times 20 times cosine of 47 degrees. And then finally, this last one is going to be, the two sides are 55 and 50. And then the angle measure is 61. All right. So at this point, we're just going to start typing stuff in the calculator. Really? Okay, now hold up here. Look at that. I missed the 2 again. Why am I deleting that 2? I don't know. I don't know what's going on with me. That's what happened on the last problem. Okay, so anyway, let's go ahead and type this in. We don't have x. We don't have a. We have x. And I don't know what it is yet. But let's type it in. Let's find out. So the square root. Oh, nope. Square root of 17 squared plus 22 squared minus, here's the big deal here, times 2. Okay, got to include that 2 or else we're going to get the wrong answer. Times 17 times 22 times the cosine of 42. So, okay, we get about 26.9 meters. Okay, so let's go to the next one and type in, really, I think I'm just going to copy this. I know I've been a little kind of loosey-goosey with the copy-paste stuff, but I think we can do this. So 20 squared plus 23 squared minus 2 times 23. Uh-oh. Oh, come on. I didn't have the 2 in there. Gosh, dang it. Wow, this calculator is just killing me. Ugh. Let's review this. Whoa, whoa, whoa. What happened there? Okay, let's double check our work here. I'm missing a 2 there. 17 squared plus 22 squared minus 2 times 17 times 22. Gosh. Let me just make sure the rest is okay. Times 22 times the cosine. Okay. So yeah, nope, that's not right. It's 14.7. Okay. Come on, Mr. Schuler. Let's get like 3 in a row here where we don't make any mistakes. Okay, so starting over, being very careful here, we got 20 squared plus 23 squared minus 2 times 23 times 20 times the cosine of 47. And we get 17.4 meters. And then for this letter C, same idea here. Just going to change these numbers. So 55 squared plus 50 squared minus 2 times 55. That's one too many 5s there. Times 50 times the cosine of 61. Fingers crossed. Okay, we get about 53.5. And that'll be centimeters, not meters. All right, there's number 12. Whew, all right, I've got a goal here. My goal is to get this right every time, okay? Hopefully, hey, if I make a mistake, I'll own up to it, but looks like all 3 of these are going to be side, 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 so we just need the one angle. So let me pull down that equation, and we can start plugging stuff in. So we're going to use this on pretty much every one. Now, these don't have names. We're just given the theta, but that's okay. We'll make the adjustments as we go. Oh, no, didn't like that. What do we need? Side, side, side. Yeah, so we need an angle measure here. There we go. Okay, so really this is going to be theta. And then we just need to make sure that this right here is going to be the theta squared, little theta. I don't think I can do lowercase theta on here. Or I guess that is lowercase theta. I can't do an uppercase theta, I don't think. But not a big deal. Just make sure that this one right here is the one that corresponds. So like in the case of this problem, this would be the 35. And then the other 2 sides, don't sweat which one's which, it doesn't matter. So this is going to be 39 squared plus 47 squared, and this can be 2 times 39 times 47. Okay. For letter B, don't worry, I'm going to go back and type that in too. For letter B, so theta is right here, so the side opposite to it is the 13, so this one right here needs to be the 13, and then these other two are going to be 9.4 and 7. And then for our last one, looks like our opposite side is going to be the 4.9. And the other one's going to be 9.1 and 8.3. All right, we're almost done. I know this has been a long homework. Jeez, I can't wait to see how much time we spent on this one. Okay, so, take all those mistakes and going back out of it, maybe it doesn't take as long, but I think this is going to be a pretty lengthy one. So let's go ahead and type this in. Inverse cosine of 39 squared plus 47 squared minus 35 squared all over 2 times 39 times 47. All right, so we get about, was that 47 degrees? Looks good. So theta equals 47 degrees. I guess it's more of an approximation, really, if we're going to be accurate about it. Okay, so yeah, there we go. Let's get out of there. Okay, so wait, I thought I switched that. What? Do I click on it again? Oh boy. This is way harder than it should be. Come on, just stick that in there. Okay, there we go. All right, so for the next one, we're gonna change the numbers up a little bit. It's not gonna be 47, I'm just kind of using it as a placeholder. We're gonna copy this and change the appropriate values. So this is gonna be 9.4 squared plus 7 squared minus 13 squared over 2 times 9.4 times 7. And we get about 104 degrees. All right, last one here, and then we're done. Yep, that's it. So let's go ahead and type this one in. (9.1) plus 8.3 squared minus 4.9 squared all over 2 times 9.1 times 8.3. We get about 32 degrees. How about that? All right, well, that's it for today. As always, let me know if you have any questions. You can always come in the morning. I can help you out. But other than that, y'all have a great day, and I'll see you next time.